right. Hello, good morning, good day, good evening, good afternoon, good night, wherever you are in the world again, and welcome to another stream here in Freaky Physics with me, Mr. Dennis. Yeah, a lot of you, some of you know my name already. Yep. Anyway, today we have a lesson for mathematics. We have Ariana today on the stream. So, since this is a lesson, just follow along. Okay. I'll let her into the classroom now. She's been waiting for a while. Ariana, hi, good morning.
Good morning.
Great. How are you today? Feeling better?
Yep.
All right, that's good to hear. All right, I've seen okay, I've been looking at your um study guide here about
hmm
exponential functions. Okay. Uh
hmm She, um, my math teacher doesn't want us to use my calculator to do like the table
yes.
thing. She wants us to just like do like the negative 1, 0, 1
Ah, okay,
with
got
the
it. I got it.
x's.
All
hmm
right, got it. So, yeah, I kind of would agree with your teacher in this case. Just to get the point.
Yep.
Then later on,
Yeah.
once you get more used to it, then that's when you use the calculator, right?
Yeah.
All right.
It's like once you master it, you get a little cheat code.
Yep, exactly. All right. So, um, okay, I'm gonna tackle this a little bit differently than from
All right.
what you have here. But anyway, end results the same. Okay.
Mhm.
So let's just go through exponential functions. Now,
Mhm.
for exponential functions, now I think at the beginning this will agree exactly the same way with the learning material you have. Okay. Now, if you have a growth, the function is f of x is equal to some number b raised to x where b is greater than 1, right?
Mhm.
Greater than 1. Okay. Now for decay, I'm just going to go straight to the functions here. F of x is equal to still b to the x, right? But
Mhm.
your b is between 0 and 1. In other words, it's a fraction.
All right.
All right. Now,
Mhm.
okay. For me though, there's another way to rewrite this. Okay. For decay, you can
Mhm.
also rewrite this as b raised to negative x, where b is greater than 1.
Mhm.
Okay.
Do you have to show your screen on your
Ah,
stream?
right. Thank you for telling me. I'm not sharing it
Yeah.
yet.
Because I'm pretty sure Classroom is connected to your stream too, so it's just like,
Yeah, that's right. So anyway, thank you for telling me. Great.
yeah.
So anyway, going back here, so that's the idea. So growth is definitely the exact same thing you would get in your worksheet. So this is exactly the same, right? But
hmm
decay, this is the one in your worksheet, right?
Like decimals.
Mm-hmm. Now, this particular thing, this is a slightly higher level. Okay.
hmm
Now, I want to go through this particular thing really quick, just so you see what I mean by that. Okay. Now,
Okay.
I believe you remember. So why the case is like this? Okay. So I believe
Mhm.
that you would remember what does a raised to n mean? We know what
Means
that means already, right? That's a raised
mhm.
to a times how many a's and
What number the n
yes,
is.
how many n times, right? Now, also,
hmm
because you know this, then I would assume you know what this means.
You flip it.
You flip it. That's 1 over a raised to n, right?
hmm
But if you think about this, 1 is actually 1 raised to any number n, right?
hmm
Okay, and that's also so that changes to that, and this still is a raised to n. Now, what happens here is I'm gonna take out that n, that exponent of n, like that.
hmm
Right? Now, isn't this very similar to that?
And yeah.
Yeah, okay. Now, this is why whenever you see this, and I hope you'll see this later on, for now, we will still practice what you have in your worksheet, okay? But
Mhm.
basically, the idea is going to be similar to this. If you have a number, and then let's just scroll up for a while again, okay? So this is the idea. If your b is less than 1, but greater than 0, in other words, this is a fraction. If this is a
All
fraction,
right.
if this is a fraction, it can be expressed as some number like 1 over a, right? Can be expressed like that.
Mhm.
So this means that this can also be expressed in this manner. Okay. Now,
Mhm.
all right. So again, that's for later. I just want to add that in case you encounter it a little bit later. Okay.
All right.
All right.
Yeah.
Now,
Yeah.
okay. So let's go straight to what an exponential function exactly is. Again, just real quick. So exponential function, as you see in your worksheet, it will always kind of exponentials gonna look like that. This is growth,
Mhm.
and then this would be decay, something like that. Oops.
Yeah. Kind of like a positive negative slope.
Exactly. So the idea of growth and decay when it comes to the exponential functions is they are mirror images of each other.
Mhm.
Okay. Which, if you look back into the fact that into this thing, if we go back to this, it kind of makes sense because the only change between b raised to x and b raised to negative x is the sign of that exponent, right?
Mhm.
Okay. Now, so again, last thing, just for the stream, just a little bit. So what exactly does this mean? If you put this on a table and then x f of x here, okay, so this is x f of x. Basically, what you're gonna do here is, let's say that your f of x equals, let's keep the number simple, 3 raised to x, right? So if I'm going to
Mhm.
put that value in negative 2, negative 1, 0, 1, and negative 2, all you have to do is put this values of x in there. So this will be, for
Mhm.
the first one, let's keep this easy first. That's 3 raised to 0, and that's going to be equal to 1. This is 3
Yep.
raised to 1. That's going to be equal to 3. And this is going to
Negative
be,
2.
oh, sorry, why is that negative 2? That should be positive. We already have the negative here.
I
Right.
just realized. I was just like, wait a
Yeah.
second.
All right, I missed that as well. But anyway, that's going to be 9, right?
Mhm.
Okay. Now, this is going to become 3 raised to negative 1, which is the same as saying 1 over 1 over 3.
Yep.
Okay. And this is going to be 3 raised to negative 2, which is
So
1
like
over
one over
3
nine.
squared, correct? And becomes 1 over 9. Okay.
Yeah.
All right. So similarly, if we do it for the other one for decay, and I'll use blue for decay, we do fx and f of x here. And since this is decay, I'm going to write the exact same function, f of x equals x raised to negative, sorry, 3 raised to negative x. Oh, sorry, let's not use that version. Let's use the other version, which is, let's
Mhm.
just say 1/3 raised to x, right?
Yeah.
Okay. So if we put that into our function, like so, and we put our numbers in again. 1, 3, 5. Okay, so negative 2, negative 1. I think I'll zoom in a bit so I can control better. Negative 2, negative 1, 0, 1, and 2. So what we're gonna put in here is we're gonna put here negative 1, 1/3 rather, 1/3 raised to negative 2. That's gonna become 3 squared, and that's gonna become 9.
9.
Okay, and here this is gonna
Mhm.
be 1/3 raised to negative 1, which is gonna become 3 raised to 1,
3.
which is 3. This is still gonna be
Yeah.
1, negative
Yeah.
1/3. Any
That's.
number raised to 0 is 1, right?
Mhm.
And then this is gonna be 1/3, and it's gonna be 1/3 squared, which is 1 over 9. So you see what we mean by that? Because we can express this as 3 What's wrong with my board? It's not writing as well as it usually does.
Hmm.
Okay, hold on.
Is
3 raised to negative 1 raised to x, and then that's going to become 3 raised to negative x. Now,
mm-hmm.
okay, so that's why either way, whether you do it in fraction form or the negative exponent form, you'll get these exact same answers.
Hmm.
Okay. Now, um, honestly speaking, since you're still learning the fractions, that's fine. All you have to really do is understand that um, the decay and the growth functions, both exponential, are again just basically mirror images of each other. Okay.
Mm-hmm.
All right. So, um, okay. So I'm gonna skip the rest of the worksheet for now, or the rest of the information from the worksheet, and let's actually start drawing. Okay. So, all right. I'm gonna ask you to do the first one, or do you want to try to do these on your own, or do you just want me to do like the first few?
Um, maybe we can do like the first one together, and then I could try to do the next few on my own.
All right, great. So let's do the first one on the exercises on growth. So this is the first problem.
Yeah.
Okay, so again, you start off by, as he said, by doing the x f of x or y or x y tables. Okay,
Mm-hmm. On a
okay.
okay.
So let's do that
Okay.
now. So we're gonna do in this case x and
Oh.
y, right?
Mm-hmm.
So let's do that again. Negative 2, negative 1, 0, 1, and 2. Okay. So
Mm-hmm.
I'm gonna do the first one here. This is gonna be 3 times 2 raised to negative 2. Now, this negative 2, this exponent of negative 2 only works on 2. So that 3 stays
Mm-hmm.
as is. And
Yep.
then this becomes 1 over 4.
Mm-hmm.
Okay. And therefore, finally, your final version of y, or the final answer here in y, that's gonna be equal to 3 over 4. 3/4. Okay.
Hmm.
Similarly, this is gonna be 3 times 1 raised to negative 1. Sorry, times 2 raised to negative 1. Okay. And that's going to be 3 times 1 half. And that's going to be 3 halves. Okay.
Mm-hmm.
This is again, so this is going to be 3 times 2 raised to 0, which is going to be 3 times 1,
Just 3.
which is just 3. I'll just write it completely. 3 times 1.
Mm-hmm.
That doesn't look like. Okay, I'll zoom in a bit.
31.
Yeah, 3 times 1. There. And that's going to be 3, right? Then the
Mm-hmm.
next one again, that's 3 times 2 raised to 1, and that's going to be 6. That's 3 times 2, right?
Mm-hmm.
3 times 2, that's going to be 6. And the last one, that's going to be 3 times 2 raised 2 squared. And that's going to be 3
Mm-hmm.
times 4. That's going to be 12. Okay.
12. Yeah.
So once we have these numbers, we're just going to plot these into the graph. So let's plot now. Let's
Mm-hmm.
start with the easiest one, x equals 0. When x equals 0, y equals
Goes
3. 1,
3.
2, 3. So we'll 1, 2, 3. We'll draw that dot right there. You know what? Blue's
Mm-hmm.
not a good color. I'll use yellow.
Okay.
Okay, it should be visible, right? Okay, then we do the next 3. You know what? I don't think we can fit it if we do it like that. So I'm gonna do it
Yeah.
like this. I think we'll do this as this is gonna be 2, 4, 6, 8, 10. Okay, that's gonna fit, right?
Mm-hmm.
So the first one again is gonna be 3, so it's
It's in
gonna
the
be here
middle.
in the middle of 2 and 4. Then the next one is 6, it's gonna be here. So this is 0, 1, 2, 3, 4, right? The
Mm-hmm.
next one is 12, so it's gonna be here. Then the one to the left, 3 halves, that's 1.5, 1.5, right? So it's gonna be somewhere here. Then the next one is 3/4, like that.
Mhm.
And then you just draw your curve as best as you can, especially that this is a curve, right? So when you do your
Mhm.
curve, just make
Oh,
sure. Okay, there we go. When you do your curve, just make sure that it's as smooth as possible, but it doesn't have to be exact. Okay, it just has
bit
to.
hard on laptop.
Yeah. And then there are just two properties you need to do. Make sure that this
Mhm.
continues up. It make sure it doesn't do that or that.
Okay.
This would be wrong. Okay, just be careful with that.
Yeah.
And then the second part here would always be you don't cross your asymptote. So do not cross the asymptote. Okay. For now,
Mhm.
because from your worksheet, your asymptote will always be the actually no,
X
the
axis.
x-axis. It should be the x-axis, right? But there's another example here. I'm looking at your worksheet right now. There's an example wherein the asymptote is not going to be the x-axis.
Mhm.
Okay, but
I'm
we'll
pretty
get to
sure it's
that.
like kinda.
Yeah.
It's
All
like
right.
kind of similar to like the curves
Yeah. The curves will always
of
be similar. They will always look like this.
like that.
Okay. For growth, decay again would go the other way. A domain is
Mhm.
here, and then let's do the range. So what's the domain? Remember that your
All
x,
real.
this is going to be all real numbers, right?
Mhm.
Okay. How about the range? The range will be from your asymptote to infinity or from your asymptote to negative infinity. It's never both. It's one or the other.
Mhm.
Okay. So in this case, you're going up, right?
Mhm.
So this is going to be to um, positive infinity. So in other words, you're going to do an greater than value, right?
Mhm.
So sorry, not x, y. Y is greater than what value in this case?
0.
0. Okay. Y equals 0. Okay. Um. Okay, that's it. Okay, easy enough, I hope.
Mhm.
All right, so let's do number 2 together. Okay. You wanna do number 2 on your own? Let's just see how.
I'll try. Yeah.
All right, I'll guide you through it if you make a mistake. Don't worry.
Okay.
All right. Okay, this is the second graph. It's okay. Here we go. The function is y is equal to 1/3 times 3 raised to x. There's a
Mhm.
shortcut, but I don't want to do the shortcut just yet. All right.
Mhm.
Okay. Let's just do it the way we did earlier.
X, Y, -2, -1, 0. Um, 1, 2. So this would be 1, 3, 3, 2. I'm gonna get it to be 1/3 times 1/3,
Mm-hmm.
which is 1, 9. Yeah.
Okay, correct.
Okay. Um.
Okay.
Wait. This is supposed to be the still down here. So 1/9 times 1/3, right?
Okay, that's correct. 1/9 times 1/3
Okay.
again.
Okay. I was just like, wait. I think I would do something right.
Right.
Um. Be 127. Yeah.
Mm-hmm. Correct.
Okay. And this is the 1/3. times 1/3 is like 1.
Okay, keep going. I understand what you're doing, even though I can't see it. My board is refreshing.
Okay. Oh.
Yeah, just keep going. I can understand what you're doing.
Okay. 9, 1, 3, 3 times 0, which just gives 1/3. Gonna box the ones that I got. 1, 3
Mm-hmm.
times 3.
Mm-hmm.
1 is just 1,
Right. Correct.
essentially.
Mm-hmm.
And then 1, 3, 3, 2, 9, 1, 3, 3. Yeah. Yep. Is it
Okay.
still not appearing on your side? Or is it.
Yeah, it's still not appearing, but yeah, I can imagine what you're doing.
Alright. So should I graph it now?
Yeah, go ahead and graph.
Alright.
Okay.
So.
If it doesn't load on my board here, you just describe to me how it looks like.
Mm-hmm. This is a. Oh, what's it called again? A growth
Okay.
slope.
Correct.
And we do not touch the x-axis.
Correct.
Mm-hmm. I'm gonna plot the 0 first because
Mm-hmm.
that's the easiest.
Right.
I think I could just do it the normal. So I'll just there, and then 1, 1,
Mm-hmm.
and then 2, 3, -1, 1, 9,
Mm-hmm.
27. So not exactly touching the line yet,
Yeah.
but it's close.
Yeah. That's fine. Remember, it's really hard to actually do it properly with with just your hand.
Yep.
So, all right. Finally, kind of loaded.
Ooh. On the other graph.
Yeah. Let's see if I can move.
Ooh, ooh, maybe.
Come on. All right.
Refresh the tab.
I'm gonna do one more refresh. See if that works. All right. But anyway, yep. The way you described it is correct. I just really want to see how it looks
Alright.
like.
I can send it into like the chat via screenshot.
Yeah, sure. Go ahead while we wait.
Okay. Okay. Copy. Here you go.
Yep. And let me see. Yep. Looks. That's correct. Very good. Great.
Yay.
All right. Okay. Do number three on your own first. Okay. Do number three on your own.
Okay. You want me to put it in myself?
Yep. Put it in by yourself as well. Okay. Can I give you a hint for number three?
Yes.
0.25 is what in fraction?
1/4.
1/4. Okay.
Yeah.
Uh, that see if it's useful. If not, just keep it as 0.25.
Okay.
Okay. Uh, okay, it's
Do you
loaded up.
think that there's a lot of too many things on here?
Maybe that. So I think I'm gonna open a new board on our next lesson.
All right,
Let's
because
just
I'm like zooming out and I could see us like drawing bigger and bigger
Yeah.
from the first lesson on this board.
Yeah. Yeah. I had the same issue
So
with the
that's
other with my other students, and well, here the thing is, we kind of oh, there we go, finally loaded. Yay!
when I added the third one.
It's getting bigger and bigger, isn't it?
Yeah, because like I like, scrolled up to see like the where we were at first, and it's like tiny compared to what we're doing right now. Because when we like, it's like it was getting bigger around the time when we were doing like the circle
Mm-hmm.
angles,
Yep.
and then it got way more bigger once we did
It's
like
blowing up
the
every time you scroll down, it blows up more, right?
it does.
Uh-huh. But I the newer boards have this feature. We tried it out with this with my other student before. It's got like a
Ooh,
box to it. So it already has a box in it by default. So you know how big you should go. Then you can just go to the left or right for extra
okay.
notes.
Ooh, okay.
Right. So okay, so now that this is loaded, correct. This is your first one. Let's see the second one.
Okay.
Mm-hmm.
So got a straight line. I don't
Mm-hmm.
know. X, Y. I think either way would work, but maybe like the fourth would be better because it's more like dividing by four than
Yes, yes, I think so too.
0, 1.
Right. Ah,
Oh,
after this, we'll do number five.
okay,
Okay, because number four is really similar to number one, right?
okay.
Okay, so I guess we can skip that.
So I don't want to write all that.
Mm-hmm.
-2 just makes 125 times 1/2,
Mm-hmm.
which is 150.
Right.
1 over 50.
Mm-hmm.
That's that's pretty big. Okay, I'm gonna 5 1. That's -1. 1. Wait, no, this is supposed to be 1/4. Hold on.
Right. Supposed to be 1/4.
This would be 1/100th. That's wow.
Yeah.
Oh,
You can touch on the drawing. You can touch the the x-axis. It's fine as long as you don't cross over. It's okay.
okay.
No, it's just an illustration. It's just a diagram. Doesn't have to be a
Yep.
100% accurate as long as you get the
Yeah.
idea.
Mhm. 1/5 times 1/4 is 1/9.
No, it's not. Try again.
Wait. Wait. No. Wait. One. I was adding
Yeah, you were adding then, crush.
5, 0, which is 1, which just makes 1/4. This one, 1, 5. I mean, 1/4 times 5 technically
Mm-hmm.
just be 5/4.
Correct.
And over here, 4, 5, 2, 25, divided by 1/4.
Mm-hmm.
I don't know if you can simplify that.
You can't really. It's already in a simplified form if it's in a fraction, right?
Yep.
Um.
And I think I can graph it now.
Yep. Go ahead.
All right. I gotta. It's 9. So -2. Oh, shoot. Oh. Figured out how to make it bigger. Okay.
Mm-hmm. You have to.
There we go. That tiny dot there. That's
Uh-huh.
the. And then 20. Oh shoot. Getting bigger. Oh, got kicked out.
Yeah, I got kicked out.
Ooh.
Just keep going, keep going. I can still imagine what you're doing as long as you describe it.
Yep. Did you already see the dots I made or no?
I kinda did, but not all of them.
All right. Yeah. One is really close to the axis.
Mm-hmm.
One of them is a bit above. One of them's around. And then you don't. You only make it like one up.
Right.
Want me to send another screenshot?
Yep, go ahead, please. Just so we can
All
I can
right.
see it. All right. I think I know what's
Yep.
happening. If you're the one writing, it kinda slows down on my end.
Mm.
So it
Trying
doesn't
to keep up.
yeah, couldn't keep up. So I guess I better get a better internet connection soon.
Mm.
I'll see if it's gonna do anything. All right, so I'm looking at your answers here for three. Yeah, that works. That definitely works.
Yay.
All right, great. So, um, all right. So for the stream, since I cannot see the stream cannot see your work, I'll just go back to my default camera. All
Oh
right.
yeah. By the way,
Uh huh.
you said something about like a. Oh shoot. Um.
About.
A shortcut on number 2.
Oh, right, right. Okay. Once my board loads properly, I'll show you. All right.
Okay.
Shortcut for number two. All right. Let's go now to no. Actually, it's not a shortcut, but it's similar. It's gonna be a similar process to number five. Okay.
Mm.
All right. Number four, if I'm not mistaken, number four should be okay. It should still be rather easy, except that you have that -2 term in there, right?
Mhm.
Okay. So number five is like that. And then for number six is the one similar to number two, but in a different way. All right.
Okay.
I think, okay, I think my board's going to load in a minute or so.
Mhm. It says you're in.
Yeah. Okay. Once that loads, we'll do number two, but with the other technique. Okay.
Mhm.
Um, Again, once you do number two with this technique, then yeah, we can do number six easily. All right. It's
Okay.
loaded. So here we go. Let's just wait for the rest of the board to load and we're good. So I'm gonna redo number two while we're waiting. Okay, copy that. All right. Oh, there. Okay. Yeah, it is getting bigger, isn't it?
Yep.
All right.
Infinite space.
There we go. Finally loaded. Okay, I'll just reset that in a while.
Mhm.
Okay. Now, what I'm gonna do is before we actually graph that, let's kind of use the idea um of the exponents to rewrite our equation, right? So here, this is gonna be, I can think of that one third as 3 raised to -1, right?
Uh-huh.
And then I'm gonna keep the 3 raised to x here. So once you
Mhm.
have multiplication of the same base, but different exponents, it's just basically you're adding the exponents up. So this is gonna become 3 raised to
Okay.
x minus 1, okay?
Mhm.
So
Ooh.
so what you can do is if you're given the other way, you can go like that. If you're given this form, you can go find the fraction first. Okay, and that's exactly how
Hmm.
number 6 kind of looks like, right? But
Okay.
before we
Yeah.
do that, let's just do the graph here for x and y. So if we do
Mhm.
-2, -1, 0, 1, and 2, okay, this is gonna become 3. I'm not gonna write the exact value anymore because we've done that before, right?
Mhm.
But this is just basically gonna become um 3 raised to uh -3, right?
Mhm.
And this is gonna become
Yeah.
3 raised to -2, then 3 raised to -1, 3 raised to 0, and 3 raised to 1, which is exactly, I'm just going to write that now. This is exactly 1 over 27, 1 over 9, 1/3, 1, and 3. Exactly the same things, right? So,
Mhm.
um, whichever technique is going to make it easier for you to graph this, it's okay to use that. So, in other words, um, you can convert this into this, or you can convert, like number 6, convert it from x minus 1 into this. Okay. Either way, if you
Mhm.
don't want to convert, it's also fine.
Mm.
But I think it's just noteworthy to see that you can translate one of these functions into the other. Okay.
Mhm.
All right. So I'll just move this number 3. For some reason it's not supposed to be there, but it is. It's just something like that. Okay. All right. So let's go to. Okay. Let's go to this last bit, number 6 first, and then we do number 5. No, number 6. Here we go.
Okay.
Okay. So for number 6, you have y equals 2x plus 5. And okay, what I'll do is I'll zoom in instead of making the image bigger. Okay.
Mhm.
All right. Great. And okay, do whatever technique you would like to use here.
Mhm.
Okay, go ahead.
Boom. Oh wait, that I have the wrong. Boom. X, Y. So -2,
-2.
-1.
There we go. It's all loaded properly. It's what you're writing is showing up on my screen now. Great.
Right.
All right. I'll zoom out a bit so you
1,
can fit that in.
2.
Hmm.
Since we're adding them, it wouldn't really fit onto the thingy.
Hmm. So what I would just want you to do now is just write the actual number now. So instead of writing 2 plus 5, just get the actual number. Plus 2 raised to -3 or whatever. 2 raised to 3 or whatever. Okay.
Okay. So 2 raised to 3,
3, correct.
2 raised to 4,
Mm-hmm.
2 raised to 5,
Right.
2 raised to 6,
Uh-huh.
and 2 raised to 7.
Okay. Huge numbers.
Yeah.
Okay. So this should be
So,
easy. I'll just write what 2 cubed is. This is 8, right?
yeah.
Okay, so the next one
Mm-hmm.
should be you just keep doubling.
Yep.
Mm-hmm.
So, 16.
Mm-hmm. This is 16, correct? Then double that again.
So 16 times 16?
No, the 16 times
Wait.
2 or 16 plus 16.
Oh, 16 times. Yeah, 16 plus 16. 16, uh, 32.
Okay, correct.
Oh, wait. 64.
Mm-hmm.
Uh, wait, no.
Okay.
Yeah.
All right. Great. I just want to count something to make this easier. That's one, two, three,
Mhm.
4, 5, 6, 7, 8. Okay, I think this was deliberately chosen so that uh yeah, you can put like 128 here.
Okay.
Okay.
Mhm.
Mm-hmm. So that's 128. And then the next one.
Oops. 64. Uh, there.
Yep. And then
Hmm.
okay. Again, no need to be exact. It's gonna be quite hard in this tiny space.
Yeah, it's weird.
Mm-hmm.
I'm just like trying to figure out the halves of all of them, so we're just like put that there. Oh.
Actually, what you said is the shortcut on graphing. What you just said is the shortcut for graphing.
Oh.
Okay. So why half? Because it's two here, right? So if
Mhm.
that was three, I'm just gonna, without solving for it, there's gonna be 3x plus 5, right? So you said half
Mhm.
because it's 2, right? So
Mhm.
times 2 every time you go right, right?
Uh huh.
Time you go right. Go right. So what does this mean? Every time you go right by one step, right? So
Mhm.
going right one step means how much do you multiply by how much do you multiply with?
By the B.
By b, in this case 3. So you
Yeah.
multiply it by 3 every time.
Mhm.
Yeah.
Mhm.
Okay, great. Now let's do the decay ones. I see that on your worksheet, the decay ones, there are 3 that are not done yet, and then 3 where the graph is given, right?
Mhm.
And your challenge, I think, for the other ones is to prove that the graph really looks like that, right?
Yeah.
Okay, so what we'll do, we have enough time for 2 graphs.
All right.
Okay, let's go to decay. Which one would you like to do first? 1, 2, or 3? Choose from the 3.
One.
1. All right, let's do 1. Again, 2 and 3 would be really similar anyway, right?
Yep.
Okay, so let's do 1 for decay. All right, I think that is, there we go. Okay, there you go.
One. Well, -2. I make them so big. Oh my gosh. Two.
Okay,
One.
I'll zoom out a bit so you can fit in.
Yeah, I just realized I can have a line tool.
Okay, I'll help you. Oh, never mind, you got that. Yeah,
Yeah.
great. Line.
I almost forgot about the. I have tools now.
Yes.
Oh, I need one more.
Uh-huh.
Duh.
There we go.
Okay.
2.
Yeah.
Mm.
So this would be 1/2, 1/2,
Okay.
2.
Okay. That's not 1/2. Remember, the first number is 6.
Oh wait. Thank you.
All right. Small mistake.
6
Small mistake.
half -2, which would make um
Okay, let's zoom in now so you can write better. Uh-huh. Uh-huh.
times 6
Uh-huh.
is 24,
Right. So I'll just rewrite that. Correct.
and 6 1, 2, -1,
Mm-hmm.
2, 12.
Mm-hmm.
And then 6, 1/2, just 6.
Mm-hmm. Okay, I'll circle the final
6.
answers.
Okay.
6. Okay.
1, just 6, 1/2
Mm-hmm.
is 3.
Correct.
6, 4, 2. Wait, no.
Mm-hmm.
1/4 of 6.
Mm-hmm.
3 twos.
3 halves. Okay, great. So on the graph. Oh, we forgot to do something. Let's go back to the others later. Okay.
Mm-hmm.
Domain and range. We forgot.
Oh, yeah. Okay.
Okay, but we'll get to that later. Let's finish this
Mm-hmm.
first.
Okay. So that's a lot of numbers.
Mm-hmm.
I'm guessing we have to like simplify some of these.
Right.
Easiness.
Okay. 24.
124 to be here.
1, 2, 3, 4, 5, 6, 7, 8. Okay, if you put 24 there, where would you put 12?
Around here,
Okay.
I think.
Mm-hmm.
Yeah.
Okay, Ken.
Mm-hmm.
Then,
Okay.
okay, just do the trick you did earlier, right? What was the trick you did
Yep,
earlier?
that's what I'm doing.
Half.
I'm trying to eye it right now because
Yeah.
I'm like, so, oh, whoops. He went accidentally clicking the.
Mm-hmm.
What did I get?
Okay, great.
Oh, I just realized something about the markers.
What is it?
Depending on how much you zoom in, will change on how big it is. Because when I change how much I zoomed in, it got smaller
Yeah, it
detail. But
does.
when I zoom out,
It
it,
does. Yeah,
it like
so
stays the same
yeah,
from your perspective.
yeah,
That's
it
weird.
does. I actually like that feature, especially if you're graphing.
I was just confused. I'm like, wait a second, why is it going smaller?
All right. So, okay, this is correct. Now, domain and range.
Mhm.
So, domain and
Um,
range.
domain, all real numbers.
Okay, correct.
I like that R.
Mm-hmm.
And range would be y is greater than 0.
Okay, great. Correct.
Because
Um,
I don't think any of them have a different. How do you say that?
a different possible
Uh,
answer.
uh, adj. The A.
Asymptote. Asymptote.
Asymptote. Okay,
Yes.
I can't say that.
Uh, okay. I think I can give you a bit of a hint on how to say that. But this is
Okay.
a this is gonna go back to pandemic days.
Oh no.
Yeah. What would you call it when you don't show exhibit any symptoms? Didn't show symptoms. You're
Uh,
asymptomatic, right? Asymptomatic.
symptom.
Because you don't
Symptom.
think
Asymptomatic.
yeah, A for none and then symptoms. No symptoms, asymptomatic,
Mm.
right?
Mm.
It's similar to
Mm-hmm.
that, asymptote. The word is kind of
Oh,
sounds similar.
asymptote.
Asymptote.
Asymptote. Asyn.
There's just a P
Asymptote.
there. So I'll just
I just remember
so asymptote
asymptote.
there. See?
Tote.
Yeah.
Asymptote.
Yeah, asymptote.
Asymptote.
Okay, there.
I just remember trying to say that in class and I failed.
Yeah, it's okay though. You know what? When I was your age, I also struggled with how to pronounce this word. When I was your age. All right. So anyway,
Okay.
all right,
I'm not alone.
you're not alone. All right, domain and range. Okay, this is interesting. Um, you will notice. Oops, what did I just do? Okay, okay, never mind what I did. But you will notice here, that all of these, you see that the exponent, you see that for all of these, the exponents are either x or x plus something. And in all of these cases, the asymptote is the x-axis, right? Okay. Now, if you
Mhm.
do number five, if you do number five from earlier,
Yep.
you would it would be different. Now, I'm going to focus now before we end. I want to focus on the what's this? I want to focus here on the decay problems on number five and six. In fact, I'll go to all of them. Okay, four, five, and six.
Okay. Mhm.
You can do and confirm these later
Mhm.
with the same technique. Okay. However, if you look at four, five, and
Okay.
six, you will notice that they all have something in common. They all have
Mhm.
this number that you either add or subtract after the exponent is there, right? Okay.
Mhm.
Now, if I graph, just gonna do it with blue. If I'm just gonna graph this, okay. Again, I could solve it and everything, but if I'm just gonna graph that, it's gonna look like this.
Mhm. Yep.
Okay. If I'm gonna graph
Mhm.
just this, it's gonna look like this, more or less. Yeah. And if I'm gonna graph
Yep.
just this, it's gonna look more or less like this. You see, you see something happening?
Uh-huh.
You see something happening? What's the pattern here?
Mhm.
What's the pattern?
That is kind of like moving it from the vertical.
Exactly. So this term here will move it plus 2, right?
Mhm.
Okay. And then this term here shifts it down, -1, right?
Mhm.
And then
Yep.
this term here again shifts it plus 6.
Mhm.
Okay. So in other words, of course, once you do that, once you do the table and everything and you confirm these, and later on, I think later on you'll be studying these things now. What do adding these numbers do? What do multiplying numbers do? This is already the start of it. So this is what adding this term does. Okay? So, last thing before we end
Okay.
today,
Mhm.
I know
It's
we're
kind of similar to like the. Yep.
yeah, similar to the other one we learned last week, right? Was it last
Yep.
week? Yeah. All right. So let's do this last
Yeah.
one. Let's do this last one here. And I'm just going to tell you the graph right now. Okay.
Mhm.
All right. 4 raised to x. Okay. And this is where we'll end after this. We went a bit
Okay.
over time. So this
All
will
right.
be 4 raised to x. So it's going to be a positive curve. I'm just going to draw a curve. It's not going to be 100% correct what that curve looks like. But what will that minus 2 term do?
It will make it move
Units. It
two.
will move it minus 2, right? So the new graph will look
Mhm.
like this. Okay. And the last thing I want to say now, not only does this move it by this much, but this is your asymptote. You notice that, right?
Yeah.
It is, right? So that's all
Asymptote.
that's gonna be
Asymptote.
yeah, that's gonna be the case. Yeah. So later on, when you're asked for the asymptote later on, it's right there on the it's right there in the formula or in the function. Okay.
Okay.
All right.
Yeah.
So okay, so that's it for today. Any questions before we end?
Mhm. Nope.
No. Okay. Um. All right. Okay.
Thank
Now.
you.
All right. So with that, I'll see you next week again. Bye bye, Ariana. Have a good
Okay.
day.
Goodbye. Have a
Bye.
good day.
Okay.
Bye.
Bye bye now.
Bye.
Okay. Sorry about that. For the stream, yeah, it's a bit confusing, but basically, um, okay. Tomoto, bye bye, Tomoto. And Akira waving, thank you for joining. Okay, for those who joined, sorry on the stream, sorry about this. There was a bit of a bug with the board. So I guess it's either the internet or something just keeps going wrong with um a bug on the site. Okay. But anyway, for next week, I'll use a more updated version of the board. So probably we can do it better next time. All right. So anyway, let's just go back real quick since I was not streaming the board. So basically, what you have to do, the main thing you have to do here is you just um, make sure you plot your points according to this. Okay. Now, um, the domain of any exponential function, whether it's decay or um, growth, is always going to be the real numbers r. The range will always be y larger than your asymptote. Again, y larger than or smaller than your asymptote. It depends on how it looks like later on. Okay. Now, the only thing we covered, and that's what I'll just do here, is here's this other one. You can work with this straight away, or if you can work on it like this by changing the exponents into -1 and then trying to see if you can put them together, you can actually do so. All right. But the more important thing here now, so again, once you put all the values in, graph and done. Okay. Now, one thing we will notice here is this +5 doesn't really affect the shifting. Okay. It affects something else, but I think we'll go through that next time. So similarly here, just put all the values in to x here, and then you get these values and done. Now, now you will notice here, and as like I said here, what I've done here is these blue boxes here. If I ignore the +2, the -1 here, and just graph it, it's gonna look, the graphs are gonna look like these blue lines here. Okay. I tried to follow the curves as closely as possible, but that's basically the idea. So what does the +2 here do? It shifts the whole graph by 2 units. And also, if you notice here, on the blue function, the asymptote is 0. Asymptote is 0. But in this new function with the +2, the asymptote is now 2. So this particular number you add is also going to become the asymptote. So in this case, I'll just finish it here. The domain here will be all real numbers. Still, it's always all real numbers. But the range here is that now y and 2. You just look at the curve first, whether it's greater than or equal to. In this case, it's going to be greater than, or rather, greater than or less than. So in this case, it's just greater than. Okay. Let's go now to number 6 here as an example again. So same thing. Blue represents the graph or the function without the +6. Okay. So what happens? The +6 shifts your asymptote 6 units up. So in this case, your domain is still all real numbers, and then the range would now be y and 6. Now just look at the curve. There is a pattern you can find. If you can find it, great. If you can't, probably next week that's what we'll do. But in this case, you can straight see it from this curve that it's going to be less than 6. Okay. All right. So we'll end that here. Before we go, though, again, thank you for joining. If you're still there, thank you for joining. Don't forget to like, share, and subscribe to the channel. We are streaming live on YouTube, Facebook, and Twitch, and we do post videos and announcements on Instagram, TikTok, and Facebook. So, again, don't forget to like, share, and subscribe. So, with that, thank you everyone for joining in. And I wish you all a good morning, good night, good evening, good afternoon, good day, wherever you are in the world. Stay freaky, everyone. Bye bye now.